All right, I know I said the last video was the last video, but this one actually is. I just wanted to break it up a little bit just because when I was looking at it, it just seemed really long, so I wanted to break up the two different sections and create a separate video over combinations. So in the first video, we talked about the counting principle, and we talked about how we just take every single event and we multiply those different outcomes together to get the total amount. And then we took a look at our permutations where the order matters, where once we have our first person out, it's out. We can't do it again, so it kind of lowers each event and the values in each event as we go down through our specific order of the books that we had on the shelf or the digits that we had if we couldn't allow repeats here. Now, what if the order did not matter at all? So permutations, order matters. Combinations, order doesn't matter. So if order doesn't matter, you're always going to have a combination. And at the end of this video, I'm going to show you a little bit of calculator tips too that you can use to check your answer. But when we're going through our practice and everything, I really want you to show all your work. So when we have our different counting pattern, one where we count permutations of a single kind of occurrence, we're going to basically take the permutations and we're going to divide out the repeats. So let's go back to this race example. So we have our PE teacher, he's awarding prizes. Now, in the permutations, we said, hey, first place maybe gets, I don't know, it gets a bigger prize. Let's say, in this case, it's more extra credit. Second place gets a little less extra credit. Third place gets the lowest amount of extra credit. But what if the PE teacher said, I don't care what place you were in. As long as you finish in the top 3, you all get the same amount of extra credit. So here the order wouldn't matter at all. And it wouldn't matter what top 3 you finish in either. So if the order didn't matter, let's say, I don't know, let's say Anson, Bree, and Caden, right? They all were racing. And we want to figure out how many different ways can those 3 get extra credit. So it wouldn't matter of who finished first, second, or third. So let's just go ahead and list out all the different outcomes that we would have. So let's say Anson came in first, Bree came in second, and then Caden came in third. All right. Well, let's say still Anson came in first, Caden came in second, and Bree came in third then. All right, so then let's say Bree came in first, and then we had Anson, and then we had Caden, and then we had Bree, Caden, and then Anson came in third. What if Caden came in first, and then we had Anson, and then Bree? Or what if Caden came in first, and then we had Bree, and then Anson? So those would be all the different ways that those 3 would be able to get extra credit. And remember, we talked about this already. This was our permutation, right? Or actually our counting principle, where we took our first, second, and third place. We're looking at just these 3 people, 3 times 2 times 1. We'd have those 3 positions, 3 times 2 times 1, because once they come in first, they can't come in again. And we have our 6 outcomes. So when we're looking at this, we had all of our permutations where we took our 30 times our 29 times our 28, right? That was our permutation. We had 30 people for first, 29 for the second, 28 for the third, because the order matters. That's our permutation that we had here. We had our permutation, which was our 30 choose 3, right? But now we want to divide out the fact that it wouldn't matter what order these 3 people came in. So I need to actually eliminate the repeats here. So to do so and eliminate all these different options, I'm going to divide out my repeats. So I'm going to divide out the fact that we have 3 times 2 times 1 repeats. So really, 3 times 2 times 1 is our 3 factorial. We're just going to kind of break this whole thing down of what we're doing. So I would take my permutations and divide it by 3 times 2 times 1. You could do that in your calculator and you would get your answer. Perfect. take 30 times 28 times 29, divide by 6. Essentially is what you'd be getting, and you're going to get your total number of outcomes, which in this case, we would get our total number of outcomes would be 4,060 outcomes. But I want to break down this guy right here to try to get our formula from here. Because I know some of you want to use formulas. I like using just this, taking my permutation and then dividing out my outcomes, or dividing out my repeats, which is just 6 factorial, or 3 factorial. So when we're taking a look at this, where our permutation came from, remember our formula for permutation. We took our n objects, so our n amount of people, so we take our 30 factorial, and to get our remaining, that 27 all the way to 1 eliminated, we divided by that 27 factorial here. That was our permutation. But then now we have this divided by 3 factorial as well on the bottom, because we got to eliminate our repeats. And remember where the 27 came from. So we had our 30 factorial. To get our 27, we just took 30 minus our 3, and then we had our 3 factorial here. I'm just trying to break this down so that way you can see where the formula is coming from. So when we're looking at our 30 here, 30 is the number of objects that we had to choose from. So we call that n. Once again, we see 30 again where we have n, but 3 was the number of positions, which was r, and 3 here is also r. So when we're looking at the combination formula, I'm making a generalized or combination formula of n choose r, we are going to have our n amount of objects divided by our n minus r factorial times our r factorial on our bottom. Once again, formula, memorize it, don't memorize it, I don't really care. I think that using your permutation and dividing out your r factorial, which is what it's always going to be, really what we're doing, because this is our permutation formula right here. We're just adding in our r factorial. So we take p of n r over r factorial. I think that's a lot easier. That's just me. Than trying to figure out this formula here. But I just want to show you where the formula came from. So we're going to reiterate kind of the combination formula. So once again, since the order doesn't matter here, the number of combinations is going to be smaller because we're eliminating some of those repeats. Because it doesn't matter how Anson, Bree, and Caden finished in that race, they're still in the top 3. All 3 of them get the same amount of extra credit. It doesn't matter. So that's the difference between what we were talking about with your permutations, where order does matter, where here order doesn't matter. And so we're going to be eliminating out some things, and we're going to have less outcomes to come to. All right, so looking at your formula, same thing that we have here. We have our combination of n choose r. N is going to be the number of objects. So the total number of people, or the total number of things that we're talking about, total number of shows, and we want to choose a specific value. So this is like the number of positions that we want. And that's going to be equal to, really it's just our permutation divided by our number of positions factorial. Because remember we had 3 positions, that's 3 factorial. That's where we got that 3 from. Or if you want to look at it this way, we have our, because we're just breaking apart what our permutation formula was, which was n factorial, and then this was n minus r factorial times r factorial. Once again, I like using this, makes it a lot easier. I can show my work a lot better, and then I can use the calculator, and I'll show you how to do that here in a little bit to choose or to look through your combination versus permutation. So let's try a few examples. So once again, if the order does not matter, you're going to use combinations. Order matters, you're going to use permutations. So looking at these examples here, we have how many different juries of 12. So there are 12 people. So this is the number of positions that we have that we're going to be filling. And this is the total number of people, which is 30 people. So out of the 30 people, we're going to choose 12 different positions. Now, if we said, hey, ordered mattered, let's do our permutation first. So looking at our permutation, we have our permutation, which we would have 12 different seats. So we have 1, 2, 3, 4, 5, 6, 12 different seats. And so I have 30 people to fill the first one. Once that person is filled there, I got 29 people to fill the second seat, and then 28 people to fill the third seat, 27, then 26, then 25. We're just multiplying all these together. 24 using the counting principle, 23, 22, 21, 20, and 19. But since the order of which I choose these 12 people, because once they are put into a group, it doesn't matter how I chose them, right? Just because you're chosen first doesn't mean that you're the head of the jury or anything else. This just means that you're put into that group and that's that. Doesn't matter when you're chosen. You were just chosen, period. So you have to eliminate your repeats. And your repeats come from your R. Just like it came from when we were talking about here, we had 3 positions. Therefore, each position is going to be repeated 3 factorial ways. So looking at eliminating our repeats, all we're going to do is divide by 12 factorial. And once again, in my calculator, you can do this. So we take 30 times 29 times 28 times 27 times 26 times 25 times 24 times 23 times 22 times 21, 20 times 19. And we're going to take that number and we're going to divide it by 12. And then remember, you have that math button. Go to PRB, down to 4, factorial. And you get your value. So we got, 86 million? So 86,493,000, or no, not million, yeah, 1,225. And that would be options there. All right, so let's try another one. So we have our volleyball tryouts. There are 18 girls hoping to make the roster. So once again, once they make the roster, it doesn't matter how they make the roster. It doesn't tell them what position they're in. It doesn't matter. So order here, once again, doesn't matter. Order doesn't matter. Therefore, we're going to use combinations. We have to remove how many ways those 18 girls, those 12 girls, because the coach is only going to choose 12 spots. So looking at how many different ways those 12 spots can be filled, we're going to have to remove those repeats. So remember, this is our N value. This is our R value, so the number of positions that we have. So I'm going to start with, we got, let's see here, we have 12 positions, so we'll start at 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positions. So if 18 times 17 times 16 times 15, 14, 13, 12, 11, 10, 9, 8, 7. All right, so because order doesn't matter, once they make the team, it doesn't matter. They can make it in the first position or the third position or the third to last position. It doesn't matter. We have to eliminate those repeats out. So I'm going to divide by the number of spots. So 12 factorial. Because that first person can be rearranged 12 factorial ways. So I got to divide those out. So once again, in my calculator, I'm going to take 18 times 17 times 16 times 15, 14. Okay, and we're divided by 12 factorial again. And we get, let's see, 18,564 different ways or possible teams that we can create. Because the order of which they make the team doesn't matter. So go ahead and pause the video. I want you to try number 3. Go ahead and pause the video and try number 3. Alrighty, so taking a look at the very last, well, second to last question, really. So you should have gotten 220 different combinations of people. Grab the label. So combinations of people here. And this could be juries options instead of juries, but it's fine. So looking here, we have 3 positions that need to be filled. 12 people total. So once the person is in the position, they can't be repeated again. So we have 12 times 11 times 10. That's that permutation that we were talking about in the previous video. Then we're going to divide out our 3 factorial repeats. So our 6 repeats, because those 3 people can be repeated 6 different ways. So we divide out our 3 factorial. And when we plug that into the calculator, you're going to get 220 combinations. Taking a look at the very last question, we have at a Dip in the Bay, our local ice cream shop, you want to choose a cone to eat. So there are 4 different types of cones, and you can only choose one. You can choose 20 different types of ice cream, and you can choose only 3. And you have 5 different types of toppings, and you can only choose 2. How many different kind of combinations can you create? Now, for the cones, it doesn't matter which order that you choose a cone. You're going to choose just one cone anyway. And for the different types of ice cream, it doesn't matter what order that you choose those ice cream, whether it's chocolate, vanilla, strawberry, vanilla, chocolate. Doesn't matter the order, you're still going to have them stacked on there. Toppings of what you're placed on there doesn't matter either. Since order doesn't matter, you're going to use combinations here. Now, we're going to choose the different types of cones, plus all the different ways that we can choose an ice cream, plus all the different ways that we can choose the different types of toppings. So that's how many combinations that we can create. So when we're taking a look here, we have all the different ways that we can make a cone, plus all the different ways that we can choose ice cream, plus all the different ways that we can choose a topping. So for our cone, we're going to have our 4 different cones, or 4 different types of cones, and we need to choose only one. So if we have our different types of cones, well, I just have 4, right? Because that's our first option, divided by, well, 1 factorial, which is just going to be 1. But besides the point, ice cream, we have out of our 20 different types, we can only choose 3. So we have 1, 2, 3 options. So we have 20 options, 19, 18 options. But we have to divide that because I can have chocolate in either of those positions. I can have strawberry in either of those, and I can have mint and chocolate chip in either of those positions. So those repeat 3 factorial. And then we're going to have our toppings, which when we're looking at our toppings, we have 5 different toppings to choose from. We can only choose 2. So looking at choosing 1, 2, we have 5 here times 4. And I want to make sure that I take out my repeat of my 2 different ways that I can repeat those 2 toppings that I choose. All right, so 4 factorial really, or 4 divided by 1 factorial just gives me 4. Okay, if I take my 20 times 19 times 18, I divide it by 3 factorial, I get 1,140. ways that I can choose an ice cream in 3 different flavors. And then I have 5 times 4, which gives me 20, divided by 2 factorial, which is just going to give me 2. It's going to be 10. And I would take 4 plus 1,140 plus 10. I'm going to get 1,154 different combinations. All right, so let me show you in the calculator how you can kind of use this as a way to check yourself. I would prefer you to show your work this way. So on your practice worksheets, I would like you to show your work this way. That's my preferred way. It's kind of where I would like you to be and what I would like you to do. It just shows me that you truly understand the difference between combinations and permutations. And really, they're basically the same thing. They kind of go hand in hand. It's really just taking a look at permutations and then dividing out your repeats, so your R factorial. That's pretty much it. So when you're taking a look at your calculator, you could type in here, looking at the different juries of 12 can be selected from a poll. So what you're going to be doing is actually going back to that math button, and you're going to scroll over to your PRB, and you can see your NCR and your NPR. So this is your combination, or sorry, your permutation. This is your combination. So the only thing is with these is that you have to type in your N first. So we type in our combination. We have our 30. We choose 12. So it's great that you could get this answer, but I need your work. So you're not going to get any credit if you don't show any of this work on your papers. Make sure you show this work. So let's see here. We have 30 math. Go to PRB. Oops, you can also scroll over this way. And we have our combination, and we want to choose 12 people. It gives us our number right there. But I want you to make sure that you can understand where this number is coming from. Okay, so we have 30 people. We're choosing 12 individuals. If the order mattered, so like for example here, we know our permutation really is just going to be this big long number here, right? Our 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7. I would get this big long number, right? That's how many permutations that we could have if the order mattered, meaning that he chose the first person that he chose is going to be the setter. Makes sense. For each position, it's going to matter. But here, order doesn't matter. It's just that they're a team. So if you wanted to find the permutation of that, once again, you have to put in N first. I always forget that because I never really use this button. So we take 18 individuals, so 18 girls. Go to the math, go to the PRB. This is going to be our permutation. And we have 12 spots. Gives us the same exact number. Now, with our combination, because we're eliminating those repeats of that person can be in any of those positions 12 factorial ways. So we divide that number by 12 factorial. If I take 18 and instead take our combination, choose 12, notice how now we get our 18,564. So once again, I need to see this work. Please, please, please. Need to see this work. This is a great way to check. This is where I want you to have your work though. So making sure you show me this piece right here is going to be really important when you're looking at your practice. And then you could also do another one. Let's do one last one and just choose, make sure we know how to use the calculator. So I have, let's see, 12 seats. I'm going to choose the fact that there are only 3 spots, so 3 seats available. Or sorry, there's 12 people, and I'm going to choose the fact that there are 3 seats available. Once again, I get 220 combinations. So you can utilize the formula, utilize this if you would like. If you're going to use the formula, show me your work as well. What is your N, what is your R, and where are we going from there? So when you're looking at your practice worksheet here, In your practice worksheet, I want you to show me or tell me if it's a permutation or combination, and then answer the question using the counting principle. So when I say counting principle, I want you to show me all of this work here, which is the counting principle. That's where all of this came from. Remember, permutation stemmed from the counting principle to begin with, and then it's just the order mattered. And then for combinations, we just had to make sure that we divided out our repeats. So make sure, once again, you tell me if it's permutation or combination. Show me this work. You can check your work using the calculator. That's great and all, but I need you to show me this work. So if you show me the work and then you get the number in the calculator, that's totally fine. I'm fine with that if you don't want to type in all the numbers. Okay. So you have 6 questions over permutations and combinations that you'll receive. The rest of the time will be yours to work on that. Alrighty. And that is the last video that we have. Have a great day.